Hi guys, Ben Hurley here, and in today's lesson we're going to go a little bit further with our LED project last time, and we're going to wire up a real physical LED from our kit. So before we get to plugging things together, let's have a look at the diagram on the website. So down here I've created a little diagram, very pictorial diagram from a program called Fritzing. You can see our Arduino there, and then it shows you exactly what you want to end up with to hook up your LED. You can see the LED has that little bent leg. The bent leg is the positive side of the LED, which is the anode. Okay, that's the one you want to connect up to your pin number 13. You can actually use whatever pin number you like, but I've done this lesson using pin 13, so it might be easy if you do that one as well. And you can see how we don't go straight from pin 13 to the LED. We're going actually through the current limiting resistor, the 220 ohm resistor that we need. That was all taken care of for us when we use the inbuilt LED, but for external LEDs we'll have to do the resistor ourselves. And then the other leg is going to be the short leg. So the bent leg is going to be the long leg on the LED, the anode. The other side, the straight leg, is going to be the cathode, the negative side. And that one just gets hooked up straight to ground. So let's have a go through, and I'll go through the physical hookup of that with you. So let's go ahead and create this circuit. I'm just going to pop the diagram up from the website so I can make sure I follow along and connecting everything together correctly. So in the diagram I've got my Arduino, got my breadboard. I'm going to start by putting in my LED. Now here it looks like it's got the anode on the right. That bent leg is the positive side of the LED. So we want the positive side is the long leg. So I'm just going to put the long leg to the right. Actually, I'll give myself a bit of room. I'll put a gap row in the middle. And then over on the anode we have our 220 ohm resistor. So I'll get my resistor, I'll connect it up on the right hand side, the anode, the positive side, and then I'll just send it over to the other, on the other side of the bridge on the breadboard. And then I just need a red wire to connect up to pin 13 where our current's going to come from. So I'll go on the end there, the other side of the resistor to pin 13. Okay, now on the other side, the cathode, the negative side, we just need a black wire to connect up the cathode directly to ground. Now because this is the only LED I'm hooking up, I'm just going to go straight to the ground pin. If I was doing a bunch of LEDs, I'd connect the ground pin up to this rail here, which would give me a lot more spots to connect up to, but we'll look at that another time. And there we are, we're done. We've got the pin 13 going to the resistor, going to the anode on the LED, then the cathode going straight to a black wire going back to ground. So let's turn him on, and we should have the blink sketch running on both the external LED and the inbuilt LED blinking at exactly the same time, because the program is just turning pin 13 on and off every 1 second. So there you go, have a go at building that circuit for yourself and see if you can get your blink sketch to run using both the inbuilt LED on the Arduino board and the external one as well. And once you've done that, down the bottom here, I've got a couple of challenges for you that once you know how to wire up an LED and code it and get it to blink, you should be able to have a go at these challenges. Number one, it says connect up 2 LEDs to your Arduino, one red, one blue, and blink them alternating one after the other like a police siren lights. Okay, so you'll need to use 2 different resistors, one for each LED. Don't try to go get fancy and put both LEDs through one resistor into the ground or anything like that. You won't have enough resistance for the 2 LEDs, and you'll probably burn them out. So definitely 1 resistor per LED, and you'll need to write a couple of different commands. You need another pin mode for the other pin that you're going to use, and you'll need some additional digital write statements to handle which one you're blinking at any given time. Okay, and then you can see my solution there in the link there. Give it a go before looking at the solution, and then if you're happy with that, have a go at the other one. The other one is to create a set of traffic lights. So again, 1 resistor per LED. You'll need 3 220 ohm resistors for that circuit. And have a think about how traffic lights work. They stay on green for quite a while, and then before going straight to red, they go on orange for a little bit. Or we've got yellow LEDs in the kit. So green for a long time, you decide how long. Yellow for a little bit, maybe a second or two, and then red for probably an equal amount of time as the green. And then usually when the traffic lights go from red to green, it's just straight red to green. So you can see if you can go through the steps of that sequence and write all of the digital write commands and the delay commands to make that work just like a traffic light. Okay, so have fun with that. Good luck, and let me know how you go. Catch you next time.